Okay, tonight's first problem is in the WebAssign is actually 1543, and I know some of us got to it in class and some of us didn't quite do that. So I'm going to go over the problem with the numbers in the book, and then you can have a nice model for when you're doing your problems tonight. All right, we're given the equilibrium reaction that 2 nitrogen monoxides form 1 nitrogen and 1 oxygen, and we're actually told that the K value is 2.4 times 10 to the third. We're also told that the initial concentration of the NO is 0.20 molar. And we're not told anything else. We're actually asked what are the equilibrium concentrations of all 3 chemicals. First, because there's nothing mentioned about the nitrogen and the oxygen initially, you can assume that they are 0. So fill that in. Okay? Skip a line and then write down, actually, the next line will be the change, and the following line will be what is happening at equilibrium. And this is what they're asking us to find out. Okay, what we're going to do here is we're actually going to define our changes in terms of x, and we're going to use the coefficients of our chemical reaction to figure that out. So, the first thing you ask yourself is, which way does the reaction need to proceed? It's pretty obvious, since there's 0 of the product, that we have to go forward and make some product. So the NO is going to go down. Ask ourselves, by how much? Well, if we say that NO is going to go down by 2x, the 2 because of this coefficient right here, then we know that the nitrogen and the oxygen both have to go up, but they're going to go up by 1x. So then we're just going to write an expression for our equilibrium concentrations. So for NO, it's simply going to be 0.2 minus whatever 2x is. Our nitrogen is going to be 0 plus x. And our oxygen is going to be 0 plus 1x. Now, all we have to do is write our Kc expression. And remember, that is products over reactants. And you raise each chemical to their coefficient. Both of these have a coefficient of 1, so you can write a 1 or just leave it like it is. It's kind of an understood one. And over reactants, our NO, and we are going to square that. We're now going to plug in our X expressions. N2 is represented by X to the first, so is oxygen, and the NO is represented by 0.2 minus 2x, and if you notice, we need to square that. That is going to be equal to the K that was given in the first place, which is 2.4 times 10 to the third. Now, I want to just show you some math tricks to help simplify this. X times x is x squared. And of course, this was 0.2 minus 2x squared. And all of that is equal to 2.4 times 10 to the third. If you recognize that you've got a perfect square on top and a perfect square on the bottom, then all you do is take the square root. But what you do to one side, you have to do to the other. So we end up getting x over 0.2 minus 2x equals the square root of 2.4 times 10 to the third, which ends up being 48.99. So we'll call that 49. And now it's a little bit simpler to find our x. we're going to kind of do, you guys love cross multiplication, so x is going to equal 0.2 minus 2x times 49. Now we're going to distribute through. Our 49 times 0.2 is simply going to be 9.8 minus 49 times 2x, which would be 98x. Now I'm going to add my 98x to both sides, and I get that 99x is equal to 9.8. So in the end, x is equal to 9.8 over 99, which is 0.099. So I'm now going to go and plug that back in to my equilibrium expressions up here. So 0.099 is going to be the value for these two. And here, if I plug in 0.099, I have 0.2 minus 2 times 0.099, and I get 0.002. In the end, it's a good idea to go ahead and put your numbers back in and see if you get something reasonably close to your original K value. So I'm going to put 0.099 in for nitrogen, the same in for oxygen, divide by 0.0020, and let's see what I get. And I get 4.9. Well, that doesn't match, so we need to try again.